The Graphosite project is funded by Innovate UK.
It's a 30-month project which started in the 1st of August 2018, and the main objective is developing that sort of structural health monitoring using graphene as a sensing element.
The leader of the project is Advanced Data. These people are mainly working on the electronics of the whole setup, basically converting the information that we get from the sensor to strain data. But the partners are also TWI, who are mostly working on the structural health monitoring part, Brunel University, which includes me, who are working in the composite materials, DZP Technologies, who are mostly working on development of the graphene ink. Zlatka is here from DZP. Haydale, working on the composite manufacturing part, and also the Cambridge Nanomaterial Technologies, who are working as in terms of management and consulting.
Of Haydale's role on the project, we're acting as an end user, defining the end user requirements. So the organisations which would be looking to exploit this kind of technology, we've highlighted that the aerospace and wind energy are key potential users due to the nature of the materials and the manufacturing processes used in these applications. So just to give you a quick highlight of some of these industries, on the left you can see a Boeing 787 Dreamliner, which uses about 50% composites in its manufacture. On the right hand side you can see a wind turbine rotor blade, so we'll perhaps be looking at making some model demonstrators of these things to highlight how sensors can be introduced into these systems.
In the Graphosite project, we are developing sensors for structural health monitoring with focus on composite materials. In this project, we use our electronic inks, especially graphene inks, but also silver, to make the sensor. The sensor is deposited directly on the surface to be monitored, and this surface can be metal, plastic, rubber, textile, more or less anything. The sensors are very thin, they're usually less than 50 microns thin, so the operation of the substrate is not affected. The sensors can be produced also as add-on sticker for retrofitting, so they can be attached after producing the composite part.
In terms of this project, PCC was mostly tasked with the modeling side of this research. So the approach that we followed in terms of this is what is often referred to as the multi-scale approach. We started with doing macro-scale models of the strain, how strain affects a ribbon, basically, of a composite material. This was mostly Nathan's work.
A bit more on the Graphosite project. We have been typically doing some tensile tests, let's say compression, bending, shear tests, and we can see here just a few pictures in which we have the tensile testing facility and the specimen here in the middle, where we can attach a graphene sensor on one side and a strain gauge off the shelf on the other side, and compare the behavior of the two so that we can understand how the graphene sensor behaves under various loading conditions. Just some concluding remarks. The Graphosite project is a very interesting project that we have been developing, and TWI's role, I think many people have mentioned this already, is mainly to validate and make consultations about types of testing to validate the performance of these graphene sensors, and this is currently work in progress.